How do we make sense of that? The difference between the observed reality and the objective reality underneath it? Or is objective reality a silly notion, given general relativity?
I'm a huge believer in objective reality. I think that objective reality
You're a fan.
is real.
Yeah.
But I do think that people kind of are a little overly casual about the relationship between what we observe and objective reality in the following sense. Of course, in order to explain the world, our starting point and our ending point is our observations, our experimental input, the phenomena we experience and see around us in the world. But in between, there's a theory. There's a mathematical formalization of our ideas about what is going on. And if a theory fits the data and is very simple and makes sense in its own terms, then we say that the theory is right. And that means that we should attribute some reality to the entities that play an important role in that theory, at least provisionally until we come up with a better theory down the road.
I think a nice way to test the difference between objective reality and the observed reality is what happens at the edge, at the horizon of a black hole. So technically, as you get closer to that horizon, time stands still.
Yes and no.
Okay.
It depends on exactly how careful we're being. So here is a bunch of things I think are correct. If you imagine there is a black hole space-time, so like the whole solution to Einstein's equation, and you treat you and me as what we call test particles. So we don't have any gravitational fields ourselves. We just move around in the gravitational field. And that's obviously an approximation, okay? But let's imagine that. And you stand outside the black hole, and I fall in. And as I'm falling in, I'm waving to you, because I'm going into the black hole. You will see me move more and more slowly. And also the light from me is redshifted. So I kind of look embarrassed because I'm falling into a black hole. And there is a limit. There's a last moment that light will be emitted from me, from your perspective, forever. Okay? Now, you don't literally see it because I'm emitting photons more and more slowly, right? Because from your point of view. So it's not like I'm equally bright. I basically fade from view in that picture. Okay, so that's one approximation. The other approximation is I do have a gravitational field of my own. And therefore, as I approach the black hole doesn't just sit there and let me pass through. It kind of moves out to eat me up because its net energy mass is going to be mine plus its. But roughly speaking, yes, I think so. I don't like to go to the dramatic extremes because that's where the approximations break down. But if you see something falling into a black hole, you see its clock ticking more and more slowly.
How do we know it fell in?
We don't. I mean, how would we? Because it's always possible that right at the last minute, it had a change of heart and starts accelerating away, right? If you don't see it pass in, you don't know. And let's point out that as smart as Einstein was, he never figured out black holes, and he could have. It's kind of embarrassing. It took decades for people thinking about general relativity to understand that there are such things as black holes, because basically Einstein comes up with general relativity in 1915. 2 years later, Carroll Schwarzschild, derives the solution to Einstein's equation that represents a black hole, the Schwarzschild solution. No one recognized it for what it was until the 50s, David Finkelstein and other people. And that's just, one of these examples of physicists not being as clever as they should have been.
Well, that's the singularity. That's the kind of the edge of the theory, the limit. So it's understandable that it's difficult to imagine the limit of things.
It is absolutely hard to imagine, and a black hole is very different in many ways from what we're used to. On the other hand, I mean, the real reason, of course, is that between 1915 and 1955, there's a bunch of other things that are really interesting going on in physics, all of particle physics and quantum field theory. So many of the greatest minds were focused on that. But still, if the universe hands you a solution to general relativity in terms of curved spacetime, and it's kind of mysterious, certain features of it, I would put some effort into trying to figure it out.